Hi everyone. So today you guys are going to take notes on mixtures, but first, if you have not done so already, please set up a new warm-up page on page 60 input. Make sure you divide it up for nice even squares, and today's warm-up just to refresh your memory after a long break. Describe the difference between elements and compounds. So feel free to pause the video so you can set that up. Meanwhile, I will go on and okay, there we go. All right, so like I said, notes on mixtures. So open up to page 61 input. You're going to set up your page just like this. Make sure you include a title up at the top so you know exactly what these notes are about. And the essential question for today, we have two of them actually. The first one is what is a mixture, and the second one is how are compounds different from mixtures. So again, feel free to pause the video, take your time setting everything up and writing everything down. So I am moving on. So first off, last week we were talking about elements and compounds, and we were seeing how they were similar, how they were different, and we saw that for the most part the only thing that they really have in common is that they are really considered pure substances. This week I'm going to be focusing on mixtures. Now mixtures are in that mixed category. Duh, this is where their name comes from. So some examples of a mixture would be maybe like a fruit salad or just a plain salad, maybe Raisin Bran, any type of cereal that has different colors that you can sort out by yourself, like with your actual hands, could be considered a mixture. So I'm going to use those examples for today. So first off, the official definition of a mixture. A mixture is a combination of two or more substances in which the substances keep their own unique properties. So that's that very, very important part, okay? That the substances that are in the mixtures have to keep their own properties, meaning, like say for example, if you have a salad, me personally in my salad, I don't like tomato and onion, so I typically ask to have those out of my salad. If not, when I get it, I can easily pick it out of my salad. Okay, if I pick out the tomato, it's still a tomato. That's how I know that a salad is a mixture. Okay, because that tomato or that substance is keeping its own unique property. It's still a tomato in that salad. So that's one example of keeping the definition of mixtures and compounds separate in your mind, okay? So just like every other example of matter, they have properties. So some properties of mixtures. One property of mixture is that they can be separated by physical means, meaning that you can literally go in with your hand or maybe like with a special filter and you can separate all the different components in a mixture. For example, in a salad, I can go in and pick out those tomatoes that I don't want, or I can pick out the onions that I don't want. Okay, I can do that with my own hands. In a compound, they have to be separated by some sort of chemical means, meaning that I have to, I don't know, boil it, or I have to cook it, or I have to add another chemical to destroy it in some way. Once I do that, then it's no longer that compound. Okay? So mixtures can be separated physically, compounds have to be separated chemically. Okay, so that's very, very important distinction that you need to remember. I can guarantee you will see that on a quiz. So come up with, actually let's change this to one question. There's only been one thing there. Come up with one question word in the question column using one of these words. Again, pause the video if you need more time. Another property of a mixture is that mixtures don't always have a constant composition. Okay, in compounds, they always have a constant composition, meaning that they're always going to have the same amount of, for example, in water, water is always going to have 88.8% of oxygen. Always, 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 always. If that changes, it's no longer water. It's probably something else. In a mixture, that's not necessarily the same, okay? Going back to the salad example, all right? Some restaurants are really, really stingy when they add the chicken on the salad or shrimp or beef or whatever it is that you have on your salad. Some of them are really stingy. Some of them are really generous. So that's when you know that it's a mixture because it's always changing. It's not always a set composition. So here I give you the example, brass is an example of a mixture because it has copper and zinc, but sometimes it can have as little as 10% zinc or up to 45% zinc. Another example that you can think of is when you make chocolate milk, okay? When you make it, you probably pour in the chocolate and make it really, really chocolatey, right? If you ask your mom to make it, she's probably going to be a little stingy with that chocolate, right? Okay, chocolate milk is a mixture because it's always changing, okay? You don't always put the same amount of chocolate in your chocolate milk. That would be an example of a mixture, okay? So remember, compounds have a constant composition, mixtures do not. Another property of a mixture is that, that they're different from the elements that form that compound. Oh, sorry. Properties of a compound are different from the elements that form the compound. In a mixture, each substance keeps its own property. So we said this before, a little repetitive, but it really is that important, okay? So in a mixture, each substance keeps its own properties, okay? Going back to the chocolate milk example, okay? If I were to take the chocolate, it's still chocolate. If I take the milk out, it's still milk. It did not change and magically turn into, I don't know, Kool-Aid when you mix them together, right? It's still chocolate milk. So I have a handy dandy little table here. You do not need to copy this down. It just helps you differentiate between mixtures and compounds as far as composition, are they joined or bonded, some properties, how they are separated, and then some examples. So we have an example of mixture would be air, seawater, most rocks. Compounds would be water, carbon dioxide, magnesium oxide, sodium chloride. The list goes on and on and on. Okay. Take a pause. I think you definitely have enough information to come up with 2 questions. So let's go ahead and come up with 2 more questions in that question column. So you should have a total of 3 by the end of these notes. Okay. And that's pretty much it. So vocab, you have your 4 vocab words, which are mixture, compound, element, and matter. These are also the 4 words that you will be using for your 4 quadrant tonight for homework. Oh, I'm sorry, no, not for tonight. Tomorrow night, Tuesday. But I'll send a note with that as well. So homework is that half sheet that the sub passed out to you, not a 4 quadrant. I repeat, not a 4 quadrant, okay? Summary. You may write your own summary or you can copy down this one, but I think this one sums it up very nicely. A mixture is blank. Mixtures can be separated by blank. Mixtures do not have blank, and in a mixture, each substance blank, okay? Easily fillable. Based off the notes that you just took right now. So we'll do a little bit of identifying, see what you think. I'm going to show you a series of photos and you're going to tell me, is it an element, compound, or mixture? So you don't need to write these down. This is just practice, okay, to kind of quiz yourself, see how well you retain this knowledge, okay? So remember, an element contains only one type of atom. Compound has 2 or more atoms joined together or bonded together. And a mixture contains 2 or more different substances that are only physically joined, not chemically. Okay? So think rocks. Are those elements, compounds, or mixtures? So what do you guys think? If you said mixture, you are correct. Good job. How about copper? What is copper? Duh, obviously, we've mentioned this already. This is an element, okay? We can find that on the periodic table using the symbol Cu. What about jelly beans? What would those be? If you said mixture, you are correct again. Good job. How about table sugar? So just regular plain old sugar that you put in your Kool-Aid. What would that be? If you said compound, good job. How about a diamond? What would diamond be? So a lot of people kind of get a little confused with this one and don't often know that actually diamond is an element. It's made up of pure carbon. So that's part of the reason why it's so expensive. How about tea? What would tea be? That would be a mixture. Okay. How about salt? What would salt be? This should be easy. We've talked about this a number of times. If you don't say that that's a compound, then we have serious problems. Okay, what about neon gas? What would that be? Duh, it's in the name, neon. It is an element, okay? A salad, I use this example. It is a mixture, okay? Pure water, keyword pure water. What would that be? You should know that that is a compound, H2O, okay? What about aluminum? What would that be? So plain aluminum would be an element, Al on the periodic table. How about lemonade? What would lemonade be? Made up of different components. We got lemon, sugar, water, maybe a little bit of ice, which is water. Yes, it is a mixture. Okay, how about silver? What would silver be? You should know that just by the name. You can find it on the periodic table. It is an element. And last one, sand. What would sand be? And if you said mixture, good job. All right, so make sure you have completed the notes. Your homework. So you see, you can go ahead and take a look on that page. You'll see that there are, I think there's 12 or 16 different little pictures there. Pay special close attention to the shapes, the colors of each of those drawings. That will tell you whether or not it's an element, compound, or mixture. It could be a mixture of elements and compounds. It could be a mixture of different compounds or two different elements. That's what you really need to pay attention to each of those little drawings, okay? So pay very special close attention to that. There is some pure elements, there is some pure compounds, but we can't necessarily say that it's a pure mixture. There is no such thing, okay? So once you are done, please make sure you raise your hand, get stamped off, and I hope you guys are all behaving yourselves. Remember, the best class gets a I'll give out some homework passes. How about that? So I'll see you guys soon, okay?